Motors. In this video, we are going to look at AC and DC motors. Let us first look at the motor effect. In a motor, electrical energy is converted into mechanical energy. That means that supplying electricity leads to movement, usually. We use Fleming's left-hand rule to decide in which direction the motor will turn. The first three fingers of the left hand are at 90 degrees to each other. The thumb points in the direction of the thrust or force, the first finger in the direction of the magnetic field, and the second finger in the direction of the conventional current. So, thumb, thrust. First finger, field. Second, current. Just a hint, practice this often, and it's always easiest to align your index or first finger with the fields before the others. Let us practice using our left hands. The first finger points to the south for the magnetic field. The second is an X for the current, which means it goes into the page. Our thumb points down in the direction of the force. It follows then that a wire in the field from a permanent magnet will feel a force when current flows through it. The magnetic field generated around the wire by the current will interact with the field around the magnet, and the two fields will push or pull on each other. Can you see that where there are opposing magnetic fields, those would attract, while like fields would repel? Using the left-hand rule, the left wire would be thrust up. The wire on the right would experience a downward thrust, and the coil would rotate clockwise. In order to increase the force experienced, we can increase the magnetic strength, increase the number of turns of wire, or we can increase the electrical current. Motors are found in toy cars, fans, washing machines, wind turbines. Let us look at a basic DC motor first. Remember, DC means direct current, so the motor turns in one direction only. A simple DC motor has only one turn of wire. This coil of wire is called the armature. The split ring commutator serves as a switch, which reverses the current after every half revolution. The commutator is made from two round pieces of copper held apart and do not touch each other, one on each side of the armature. A piece of carbon or graphite is lightly pushed against the copper to conduct the electricity to the armature. The brushes maintain electrical contact between the battery and the turning commutator. Using Fleming's left-hand rule, we can determine in which direction the motor will turn. In the vertical position, the gaps between the commutator segments are bridged by the brushes, and the current is therefore short-circuited for a moment through the commutator, and no current flows in the coil. The motor keeps turning due to the armature's momentum. In the diagram, the left side of the armature experiences an upward force, and the right side of the armature experiences a downward force. This produces a torque which turns the motor clockwise. As the motor rotates, first one piece of copper, then the next, connects with the brush every half turn. Because the current would push wires in a particular direction and they could go no further, the split ring commutator is needed. The wire on the left side of the armature always has current flowing in the same direction, and so the armature will keep turning in the same direction. If we look at diagram 1, current in this arm is flowing from left to right. In diagram 2, current stops flowing momentarily in the coil, but inertia will propel it to make contact once again, reversing the current in the coil. In diagram 3, current in the same arm reverses, flowing from right to left. So the split ring commutator makes the current inside the armature change directions or alternate. What happens when we use current that is already alternating? In an alternating current motor, the brushes are always connected to the same part of the coil in the motor. The attachment of the slip rings to the armature can be seen in the diagram. As the current direction changes with every half turn, the graph would be seen as a sine graph. The direction change is shown by the graph going below the time axis. The major difference between alternating current and direct current machines is how they are connected to the outside circuit. Let's recap what we've learned in this lesson. A motor uses electrical energy and converts it to mechanical energy. A DC motor has a split ring commutator, whereas an AC motor has slip rings. It is recommended that you make a list of the parts of a motor and what their functions are, because these are commonly asked questions in exams. So brushes are made of carbon to make contact with the external circuit. The armature carries current in the motor and acts as a solenoid. The magnets provide a magnetic field. The only part that is actually different in AC and DC motors is that AC motors use slip rings to connect the armature to the brushes, whereas the DC motor uses a split ring commutator.